Hello, previously I've mentioned the talk that I'm going to give at PHP South West in August. That's August the 8th, which is a Wednesday. I've mentioned that I'm going to do the talk, but I haven't actually discussed what I'm going to be talking about, and that is essentially what this video is basically going to be about. I'm just going to dump and offload some ideas that I've got for that talk on Wednesday the 8th. Now, before I get started, I just want to say that the talk will be far longer than any of the other talks that I've done at PHP South West and in other places, because normally I would do a lightning talk, which is like a 10-minute long talk, but this is actually 30 to 45 minutes, so it is far longer, and therefore the structure is slightly different. There's obviously more content that is required. So I have a number of thoughts and suggestions on what I could talk about, and I've basically narrowed it down to one specific topic, because obviously you don't want to talk about everything under the sun. So one specific topic that I would like to talk about is software complexity. This is something that has been on my mind for a very long time, about how software is extremely complicated and how we make it even more complicated than perhaps it should be. So software complexity is the topic for the talk. Complexity in software has been discussed on many different levels in many different topics, and people have written blog posts about this, and people have actually written papers about this as well. One particular paper that I've fallen in love with is a paper by Fred Brooks, and if you look up this paper, you'll probably find a Wikipedia entry about the no silver bullet, which is essence and accidental complexity in software. So what I would like to do in my talk is discuss those points. I might do it so the first half of the talk is on essence or essential complexity, and then the second half is perhaps accidental complexity. I find this quite fascinating because you don't actually have to look upon this as just a software issue. This can actually be templated and molded into everyday world scenarios. Usually when someone is trying to create something and is doing it from someone else's design specifications, so be it whether you're building a car, an aeroplane, a computer system, or what have you, you have two very distinct sets of complexities, one being essential complexity and the other being accidental complexity. And the really interesting thing about these two areas of complexity is that one is very static, one is very defined, and one is created by us developers, or the people who are actually putting into practice whatever the system requires. So again, if I was to build a car, it would be the people who actually build the car, the engineers and so forth. The essential complexities would be set out by the people who decide what the car should look like, should behave like, and so forth. Let's focus on essential complexity for the time being. This is complexity that is well defined by the requirements that the developer is trying to build from. So if you have like 5, 10, 15, 20, 30, 100 requirements, features that this software has to cope with, has to have, then they are complexity points. They are essential to the system. I like to call them intentional complexities, because these are complexities that are essential, intentional to the system. They are intentionally there. If the system was less feature-rich, then of course it would have less complexity points. And when I say points, I don't mean like, Scrum points or whatever, or story points. You could, I guess, map those to those other kind of ideas and processes. Like the more complex something is, the more story points you might give it in a kind of an agile kind of way. Although I don't really want to navigate those kind of waters. But an essential complexity is a well-defined or I should hope are well-defined. It is a defined feature. The beauty with essential complexity is that if you're in a team that creates PRDs, and I hope you are in a team that creates PRDs, product requirement documents, actual documents that list all the features that are required for the product, i.e. the application that you're building, to be acceptable for release, right? You can look at those like a shopping list. These are all the things that need to be done in order to actually release the system. And you have them, you can see them, you can see where you are in the system, you can cross them off as they go. And by crossing them off, you're reducing the overall complexity that is left over to allow you to finish the product. So, and one would hope that as you are crossing off these complexity points, as you're actually building and developing these features, you're also building a system that is more adaptable to future features, or features that aren't yet created but are on this PRD document. So what I'm saying here is that you would hope that you would create some code that you could reuse later on in the project's lifecycle. And obviously when you start a project, you're building the foundation. So it might be that the first thing you do is that you install, I don't know, Symfony or MySQL or the AWS infrastructure or something, the foundation stones. That could be the first level of complexity. In order for this to be acceptable, it must have a database, a web server, a message queue, an email server, and blah, 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 blah. And so you tackle all of these points. And then one would hope that as you go down the PRD, things start becoming a little bit more easier, because you can go, yes, I've already created this little component that I can use here for this feature. It doesn't always work like that, of course. Some features are quite isolated, and that's fine. But there are times where you can sort of like reuse the code that you've created for a particular feature, or you architect the system in such a way that makes it easier for future features that are defined but haven't been created yet. Now, the thing is with essential complexity, and I can only vouch for the software world because that's all I know. But I would imagine that this is the same for other industries. The software complexities, or the complexities in software that are essential to the system, should be well defined before the system is being built. Correct? However, the amount of times I've gone into meetings and I have heard the words, wouldn't it be nice to have? Wouldn't it be nice to have this feature? Wouldn't it be nice to do this? If you've got some time, could you just slip this in? Or as you're in that area, I just thought we could add this. Those kind of things. The thing is, with essential complexity, it should be, in my opinion, very static, right? This is what's been agreed, and therefore this is what's going to be built. Obviously, you do need a level of flexibility, but often or not, when things start getting added and changed into the system, that makes the rest of the features that you're trying to develop to get this thing done, to match all of the essential complexities that the system has, you end up rushing, you end up squeezing things in left, right, and center, and it is difficult. It is difficult. And there is a challenge when you go ahead and accept to do this, to do an additional complexity on the system, because you are therefore setting a precedent, an expectation that just because what's defined on the PRD document doesn't mean that that's going to be the final thing. It's kind of like a working document. You don't want people to think like that. You don't want to think that this is actually a working document. You want to be in a position where you can say, yes, I know exactly as a developer, as a coder, what I need to do based on this document that I was given at the start of the project. You don't want to come at the end of, say, the last 2 or 3 weeks and then have someone say, wouldn't it be nice to have this? Or let's postpone deployment until we also add this new founded feature. So that is a challenge that we all have to deal with as developers. And it's a challenge of knowing when to say no and when to say yes, when to accept that there needs to be additional complexities into the system, but we need to obviously justify our reasons why essential complexity isn't a great idea just to add things on. The complexities are just growing and growing and growing without any form of justification. And that's the key, justification, justifying why additional essential complexity needs to be added during the project's lifecycle. So, for example, if a client came to me and said, instead of this needing to be blue, we want it to be red, or instead of this footer looking like this, we want it to be like that, or instead of these pages being called that, or whatever, I would ask, perhaps, what is the justification as to your reasoning? And can you have any kind of metrics on whether or not that is acceptable from the user's point of view? So 9 times out of 10, someone's had a very great idea in the shower, right? Oh, I've just thought of this fantastic idea and I'm going to see if I can implement it into the system whilst the system is being built. Fine. But without any kind of a justification as to why this new thing needs to be added to the system, then all you're doing is you're increasing essential complexity, and therefore you're increasing the time it takes to actually meet all of the other areas of complexity, the time it takes to actually deploy the system. And I think of it like this. So if you go to 2 restaurants and one restaurant has a menu that has 100 items on that menu, so you could choose from 100 dishes. You go to another restaurant and that only has 15. Which one is more complicated? Which one is going to take you longer to decide what you want to eat? Well, it's going to be option A, isn't it? Option A with the restaurant that has 100 menu choices, because it's overly complicated. Because, and you know, there's other reasons why that restaurant is going to fail, because they haven't found the niche or what have you. But it's overly complicated. We as human beings cannot compute all of those factors very easily. And you're increasing the amount of complexity that your kitchen staff has to cope with. Also, not only the kitchen staff, but the waitresses and the waiters, basically everybody in that system now has to cope with a level of essential complexity. So, for example, if you have 100 menu items and say 25% of those menu items, so 25, were off the menu, then you have to, as a waiter or waitress, remember which ones were actually off the menu, which ones aren't available, and then talk to the person that you're waitering on to just remind them that, oh, this isn't available, and this isn't available, and this isn't available, and so forth. So basically, by reducing the amount of essential complexity, you simplify the choice. Whereas when you go to the restaurant that has only 15 menu items, and personally that might even be too much, but if say 15 for instance, that is a simple answer because you can easily compute those. Of course, the opposite of complications is simplification, right? So you're simplifying the problem, which is what I've been talking about in the whole menu scenario. The more simplified it is, that the software application is, the easier it is on every level. And I'm not just talking about developing code here. I'm talking about deploying it. I'm talking about testing it. I'm talking about integrating it into the rest of the system. If you've only got small amounts of features, then it's easier to develop. It's easier to create. And 9 times out of 10, these nice-to-haves, if they haven't been well thought through in the sense of, will the customer, the end user, will the viewer, will the person who's actually using this application use this new feature that I've just come up with, then it is just going to prolong the application, prolong the deployment, prolong the testing. Sometimes it just doesn't get used. You'll find in a lot of these big websites like Facebook and Amazon and so forth, and YouTube even, when they come to actually roll out some new features, they do it in a drip-feedy kind of manner. They slowly bring things in. It's not a massive, huge, big bang release. This is the difference between sort of features coming into an existing system and features being added to a non-existing system, a system that doesn't exist yet, something that has been built or is being built by scratch. It's a different mindset because when you're building something from scratch, you don't actually know if it's going to work. Right? You don't, because it's not live yet. It's not done yet. And this really kind of moves into the requirement of being very well focused. When you're actually deciding on features of a system, you kind of need to be extremely focused and well defined as to what this system has to do in order to achieve its acceptability. And often the new features, these nice-to-haves on a system that is being developed for the first time, they will definitely prolong the deployment process, the actual process of getting it to market, but they will also pollute the current feature set. And that is something that you don't want to do. You want to think about basically like a mission statement, what it is that your system needs to achieve. It should only do those things in the first release. Have you ever been on to like a web system and you have these little pop-ups? If you haven't been there for a while and you log in and you have these little pop-ups and it says, these are the new features that have come through. And then like 20 minutes later, you're still pressing next and you're reading and you're like, God, why on earth am I doing all of this? I'm here because I want to do something on this system. The same thing as I wanted to do last week, but now I'm having to learn all of this new stuff, all of these new features. Why can't you just do these in very small iterative processes? And that's what a lot of these big companies, as I said, do. When you log into Facebook or YouTube and you notice some small features that are added, it's never a humongously big bang release of features. It's usually very small increments. Like, for example, with the menu thing, the restaurant analogy I mentioned, if you were to increase your items on the menu, then you shouldn't be doing suddenly an extra 5 things. You should be doing an extra one a week, or reducing one, taking one off and putting another one on. Therefore, the number of complexity areas on that menu is still the same. It's just you've changed a particular menu item. You don't let it grow and grow and grow and grow and grow, because when you do that, you lose the mission. You lose the essence of what your restaurant is all about, what your system is all about. So that is essential complexity, or as I like to call it, intentional complexity, because I think the word intentional is a little bit more dramatic. It's intentionally adding to the complexity of the system. Accidental complexity is the opposite of essential complexity. Accidental complexity is on us, the developer, the engineer, the person who is actually developing the system. Because often we go, oh, it's a piece of software, it's something that we're having to develop, let's go and overcomplicate it. And we often do that. We often fall into that trap where we look for a very complicated solution to one of these bits of essential complexities. And it's a bit troubling, because I do this all the time. I overcomplicate things all the time. I end up writing lines and lines and lines of code and then scrubbing them out when I've come up with a simplified solution for it. But a lot of the time, the complicated problems spawn off other complicated problems. So, for example, it could be that you come up with a wrong solution to one of these complexity points, and that solution has more complexity in there that warrants it to be the actual solution for that feature. So the architecture could be wrong, the infrastructure that you're using is wrong. You could accidentally build something in a way due to your naivety of the system, due to your unexperiencedness of the software, of the language that you're using, or the system could grow and scale and your system could not cope with that. Or you could be running tests that you think are perfectly acceptable because it's just you running those tests, but when it actually goes out to the wild, those tests fail because you haven't thought of the number of requests coming into your system. So here I'm talking about loops. So when you create a loop, or a loop within a loop within a loop within a loop, yeah, I've seen some of those. You think, okay, my sample size, my test size is say, I don't know, 100 test users, and I'm going to run some acceptance tests on this and just make sure that this all runs very smoothly and very quickly. And that happens. Then suddenly you put it live, and of course your daily traffic is hundreds of thousands, and then suddenly it falls flat on the face, and you're thinking, well, it worked on my machine. Why doesn't it work in production? And it's because you haven't thought of the environment, the differences in environments. So the differences in how the users are going to use the system. It could also be that some of the users that are in production ready may have an account that is completely screwed up, messed up because of another feature that they've gone through. And so perhaps your tests haven't mapped to those kind of user processes, the previous user processes. And so your sample size is incorrect. So it's not a good reflection to that. And that is an accidental complexity. It is an accident on your behalf as a developer. You don't mean to make the thing more complicated, but you do, because perhaps you don't understand the software, perhaps you don't understand the language, perhaps you didn't anticipate the issues with scalability, perhaps you don't anticipate the security issues with third-party libraries and so forth. But also, a lot of it is to do with bad design. So this is where you design the system badly. And again, that would come from the inexperience, the unknowingness, the just not having the enough knowledge on what it is that you're doing and the implications that has when it's in production. Accidental complexity could, of course, come from the database. So this is where the schema just doesn't fit what is going on, doesn't work with the scale of people going through. Maybe the database just hasn't been upgraded. Maybe the PHP hasn't been upgraded. Maybe the infrastructure is so old. Maybe you've forgotten to turn log rotation on, and therefore the server falls down because the disk space runs out. Maybe you haven't added the alerts to monitor that. But the thing is, there are so many little points like this that one has to consider when they are a developer. There are so many things that could go wrong. There's so many cogs in the system that accidents do happen. And this is where, accidental complexity comes through. The system fell down because you didn't have log rotation on, because your log files just got way huge, because you didn't have your alerts on. Okay, you weren't notified of that. But then you wouldn't think that you would need to be notified of that if you only had a few hundred customers. That would be fine. But you didn't anticipate the scale of this application. Suddenly it goes viral, and then the next morning you find out that something has gone incredibly wrong because the system that you've created, the schema that you've designed for the database, the loops that you've created don't match the sample size that you've tested them with. Accidental complexity can also be when a developer overgeneralizes the feature, overgeneralizes what the system needs to do. And then what happens is they try and abstract this to the nth degree. And in fact, going back to the mission of the system just gets so distorted, gets so overgeneralized that it is just, you're trudging through treacle in order to do anything because everything is so abstract. Because a developer has thought, it might need to do this, and therefore we're going to take it back. Or I don't like the fact that code is being used again and again and again, so we're going to abstract this out and abstract this out. And it just gets so bloated and just so difficult to understand and to reuse later on. Because in fact, when you're over abstracting something, you're actually making it a smaller target for a specific succinct feature, which is very difficult to latch on or snap together with other features, unless you've really thought about the whole business idea and also taken into account what might be coming up in the future. Abstracting code to the nth degree is not always the best thing. It can lead to large amounts of complexity when you want to try and do a very small change, but then you have to configure that small change in like 15 million different places just to get the damn thing to work. Overgeneralization, over-abstracting can be a challenge. Also, overgeneralization means when you are giving a task to a developer, and that developer not only does that task, but just completely goes the extra mile and a half. And you might be thinking, well, surely that's a great thing. Surely a developer who likes to go the extra step, that's obviously a good thing. And yes, it is. But let's just say you have given a developer the task of just give me a list of all of the letters in the English alphabet. So we've got a feature that's come through, and we need to list out all the letters in the English alphabet. And you give that to a developer. A week goes by, and you're like, why is it taking a week for him to come back to me? So I'm going to speak to the developer and see what's going on with this project. Perhaps it's just been, left somewhere. So you go there and you discover that, yes, you do have a list of English letters in the alphabet. Fine, you've got that. That is what you've asked for. But you've also got a user interface that allows you to drag and drop and change the order of these letters in the English alphabet. You've also got a content management system that allows for different languages to be added and created. And now you've got extra complexities, because not only do you have to maintain the list that was the thing that was asked for, but you've also got to maintain the content management system. You've also got to maintain the user interface. So that in itself is 2 extra levels of complexity that wasn't requested. And the developer in question has probably gone the extra mile because he wanted to please. He wanted to show that he was capable of all of those skills. But the project has been bloated because of all of that. And you have to maintain all of this stuff unless you remove it. And removing it is obviously the best solution here, is to go, I only asked for the list of English letters, and that is all we need, and that is all we will use. And if we were to use everything else, we would have to maintain everything else. So overgeneralization not only means being extremely abstract, but it also means doing the extra mile, doing things that aren't essential to the system. Accidental complexity is rife within legacy code for various reasons, one of which is that when code works, it doesn't matter how bad the code is written. If the code works, then often people leave it alone and back away from it. And they see it like a black box. It just works. You don't ask any questions about it. It just works. You just back away. And when you do start investigating, if you have to, then people like to do it from a distance using a very long stick, and they give it a prod just to make sure that it's still running as expected. And a lot of the time, even if the company is hemorrhaging money just to support this legacy piece of code, they will try and do so without bringing developers in to actually see if they can make it any more efficient. Because half the time they're worried about the new features coming in, so they want to work on the new stuff. They don't want to be working on making the existing stuff any more efficient. And it takes a particular developer to be able to look at the legacy code and go, yeah, I could make this a little bit more efficient. I could save the company money by changing the amount of calls here, by reducing the amount of database calls, by doing these kind of upgrades. It's a bold thing. It's a bold step to take, to actually look and take upon legacy code and actually get to the nitty-gritty bits and pieces of it. It's a very bold thing that developers have to do. We don't like doing this. When something just runs, it's the kind of the mentality of, if it is fixed, if it works, then don't fix it. There's no point. But in actual fact, with software, things start getting very inefficient very quickly. Technology changes all of the time. And of course, if you're not moving as fast as you should be, then you're going to start missing out. And it could be that you're wasting a lot of money because the code has been written in a very inefficient way because of an accident that a developer has gone through, has created it in such a way because they didn't anticipate what it's currently doing right now. And I've been working on systems that are like 10 years old plus, and looking at code and trying to get into the mindset of the developer as they were developing it 10 years ago. And of course, if something is currently running, if something is currently working, and if people are currently using it, it doesn't matter how bad the system is, you don't really want to touch it because it works to a degree. So whatever you do, you obviously have to make it better and more efficient, and that is the goal. But it is a struggle working on legacy code. The beauty, of course, with accidental complexities is that we as developers, we can create and therefore we can fix these accidental complexities. It's on us. We are responsible for these accidental complexities that are in the system. So we can create them, we can fix them. So this is the talk that I want to give at PHP South West on August the 8th, all about software complexities, not only from the developer's point of view, but also from the point of view of actually coming up with the features for the system, the essential complexities, the intentional and the unintentional complexities of a system. Thanks ever so much for watching. Happy coding. And if you are there on August the 8th, then do let me know and I'll come and say hello. Cheers. Bye.